The use of type THHN wire in electrical installations, specifically those with ampacities below 100 amps, can indeed lead to violations of electrical codes, particularly concerning Section 110.14 of the National Electrical Code, or NEC. This section addresses the temperature limitations of conductors and their impact on ampacity, which is the current carrying capacity of a wire in amps. The NEC mandates that the ampacity of conductors be selected based on specific temperature ratings depending on the application and equipment involved. For equipment rated 100 amps or less, and for conductors rated up to 100 amps, the termination temperature rating is generally limited to 60 degrees Celsius. For equipment rated over 100 amps, the termination temperature rating is generally limited to 75 degrees Celsius. There are exceptions, such as for motor applications where high temperature ratings may be permitted, but these are specifically defined and do not apply universally. The core issue with using THHN wire for applications under 100 amps lies in the fact that THHN wire is typically rated for 90 degrees Celsius for dry locations. While it is permissible to use a wire with a high temperature rating, the ampacity used in calculations must correspond to the temperature rating of the termination points, or the equipment to which the wire is connected. In scenarios where the equipment is only rated for 60 degrees Celsius, the ampacity of the THHN wire must be derated to align with the 60 degrees Celsius ampacity rating. This is where the problem arises because THHN wire does not have an ampacity rating at 60 degrees Celsius listed in the NEC tables. The NEC provides ampacity tables such as Table 310.15b16, which list the allowable ampacities for various wire types based on their installation temperature rating and the ambient temperature conditions. These tables typically provide ampacity values for 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. Since THHN wire lacks a listed ampacity at 60 degrees Celsius, you cannot directly use the wire for applications requiring a 60 degrees Celsius termination temperature rating. The correct approach is to select a wire type that has a listed ampacity at the required temperature rating, or to use a wire with a high temperature rating and apply the appropriate derating factors. However, in the case of THHN wire and 60 degrees Celsius terminations, derating is not a viable option because there is no starting ampacity value at 60 degrees Celsius to begin with. Therefore, using THHN wire for applications under 100 amps where the equipment is rated for 60 degrees Celsius would be a violation of 110.14 of the NEC. The proper course of action is to use a wire type such as type TW or type THW, which have ampacity ratings at 60 degrees Celsius, or to use a dual-rated wire such as THHN/THWN, and use the THWN ampacity which is rated at 75 degrees Celsius in a wet location, or 60 degrees Celsius. Another option is to use a wire with a 75 degrees Celsius rating, provided that the equipment terminations are also rated for 75 degrees Celsius. To ensure compliance with electrical codes and regulations, it is essential to carefully consider the temperature ratings of both the conductors and the equipment terminations. Proper wire selection is crucial for maintaining the safety and integrity of electrical systems. Ignoring these requirements can lead to overheating, insulation breakdown, and potentially hazardous situations such as electrical fires. In summary, the use of THHN wire for applications under 100 amps without considering the temperature limitations outlined in 110.14 of the NEC is a violation. It is imperative to select the appropriate wire type and ampacity based on the specific requirements of the installation to ensure safety and compliance. Always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when designing or installing electrical systems. This ensures adherence to best practices and minimizes the risk of electrical hazards. When dealing with electrical installations, a thorough understanding of ampacity and temperature ratings is paramount for ensuring safety and code compliance. Let's delve deeper into the intricacies of these concepts and their practical implications. Firstly, ampacity refers to the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. This rating is determined by factors such as the conductor material, size, insulation type, and the surrounding environmental conditions. The NEC provides detailed ampacity tables that list the allowable ampacities for various conductor types based on these factors. Secondly, temperature ratings are critical because excessive heat can degrade the insulation of a conductor, leading to short circuits, ground faults, and potentially fires. The temperature rating of a conductor specifies the maximum temperature that the insulation can withstand without deteriorating. As previously mentioned, common temperature ratings for conductors include 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. Section 110.14 of the NEC addresses the temperature limitations of conductors and their connections. It stipulates that the temperature rating of the conductor must be selected and coordinated with the temperature ratings of the terminations and equipment to which the conductor is connected. This is crucial for preventing overheating and ensuring the safe operation of the electrical system. The NEC outlines specific requirements for selecting the appropriate temperature rating based on the ampacity of the circuit. For circuits rated 100 amps or less, the general rule is that the conductor must be selected such that its ampacity corresponds to the 60 degrees Celsius column in the ampacity tables. For circuits rated over 100 amps, the conductor must be selected such that its ampacity corresponds to the 75 degrees Celsius column in the ampacity tables. There are exceptions to these rules, such as for motor circuits, where high temperature ratings may be permitted. However, these exceptions are specifically defined and must be carefully followed to ensure compliance. In the case of THHN wire, which is commonly rated for 90 degrees Celsius in dry locations, the ampacity must be adjusted to align with the temperature rating of the terminations and equipment. If the terminations are only rated for 60 degrees Celsius, the ampacity of the THHN wire must be derated to the corresponding 60 degrees Celsius value. However, as previously mentioned, THHN wire does not have a listed ampacity at 60 degrees Celsius. Therefore, it cannot be used in applications where a 60 degrees Celsius termination temperature rating is required. To illustrate this point, consider a 20 amp circuit supplying general-purpose receptacles in a residential dwelling. According to the NEC, the conductors for this circuit must be rated for at least 20 amps. If THHN wire is used, its ampacity would need to be derated to the 60 degrees Celsius value. However, since THHN wire does not have a listed ampacity at 60 degrees Celsius, it cannot be used for this application. Instead, a wire type such as type TW or type THW, which have ampacity ratings at 60 degrees Celsius, should be used. Alternatively, a dual-rated wire such as THHN/THWN can be used, and the THWN ampacity rating, which is applicable in wet locations and is typically rated at 75 degrees Celsius, can be used if the terminations are rated for 75 degrees Celsius. In summary, the proper selection of conductors and their ampacity ratings is crucial for ensuring the safety and reliability of electrical systems. The NEC provides detailed guidelines for selecting the appropriate temperature ratings and ampacity values based on the specific requirements of the installation. Ignoring these requirements can lead to overheating, insulation breakdown, and potentially hazardous situations. Always consult the latest edition of the NEC and seek guidance from qualified electrical professionals when designing or installing electrical systems. This ensures adherence to best practices and minimizes the risk of electrical hazards. Furthermore, it is important to consider the impact of ambient temperature on conductor ampacity. The NEC provides correction factors to adjust the ampacity of conductors based on the ambient temperature. If the ambient temperature is higher than the reference temperature listed in the ampacity tables, the ampacity of the conductor must be reduced. Conversely, if the ambient temperature is lower than the reference temperature, the ampacity of the conductor can be increased. These correction factors are essential for ensuring that conductors are not overloaded in high-temperature environments. Another factor to consider is the number of conductors in a raceway or cable. The NEC provides adjustment factors to reduce the ampacity of conductors when multiple current-carrying conductors are installed in close proximity. This is because the heat generated by multiple conductors can raise the temperature of the surrounding insulation, reducing its ability to dissipate heat. The adjustment factors vary depending on the number of conductors and the type of raceway or cable. In addition to these factors, it is also important to consider the voltage drop in a circuit. Voltage drop occurs when the voltage at the load end of a circuit is lower than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of conductors. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to increase the size of the conductors. In conclusion, the proper selection of conductors and their ampacity ratings is a complex process that requires careful consideration of various factors. The NEC provides detailed guidelines and requirements to ensure the safety and reliability of electrical systems. By following these guidelines and seeking guidance from qualified electrical professionals, it is possible to design and install electrical systems that are safe, efficient, and compliant with all applicable codes and regulations. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable performing electrical work yourself, hire a qualified electrician to do the job. They have the knowledge, skills, and experience to ensure that the work is done safely and correctly. Always disconnect power before working on any electrical circuit. Use appropriate personal protective equipment, such as safety glasses and gloves. Follow all applicable codes and regulations. If you are unsure about any aspect of electrical work, seek guidance from a qualified electrician or electrical inspector. Electrical safety is everyone's responsibility. By following these guidelines, we can all help to prevent electrical accidents and injuries. Keep in mind that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional for specific recommendations regarding your electrical system. The National Electrical Code is a complex and ever-evolving document. It is essential to stay up to date with the latest changes and revisions to ensure compliance. Consider attending electrical training courses and seminars to enhance your knowledge and skills. Continuous learning is crucial for staying ahead in the electrical industry. Also, remember that electrical codes and regulations may vary depending on your location. Check with your local authorities to determine the specific requirements in your area. Compliance with local codes is essential for ensuring the safety and legality of your electrical installations. In addition to the technical aspects of electrical work, it is also important to consider the ethical implications. Electrical professionals have a responsibility to uphold the highest standards of integrity and professionalism. Always act in the best interest of your clients and the public. Avoid conflicts of interest and maintain confidentiality. Adhere to ethical principles in all your electrical work. Finally, remember that electrical safety is a shared responsibility. Encourage your colleagues, friends, and family to learn about electrical safety and to follow safe practices. Together, we can create a safer environment for everyone. Electrical work can be challenging and rewarding. By staying informed, following safe practices, and upholding ethical standards, you can make a positive contribution to the electrical industry and the community. So embrace the challenges, stay curious, and never stop learning. The world of electricity is full of exciting possibilities.